and a warm welcome to everyone who has joined this session. And basically, we are going to start with our webinar, which is on topic professional grade desktop 3D printers for fiber reinforced composites. It is organized by Shreerapidtechnologies, co-partnered with Race 3D. I am Sonal Khoth, Assistant Marketing Manager at Shreerapidtechnologies. I'll be the moderator for this webinar, and let me introduce you to our Pratik, who is application engineer at Shreerapidtechnologies, who will be the panelist for our webinar. He is basically from background mechanical engineering background and postgrad in plastic technology. Pratik has an immense knowledge about 3D printing, and he has been in this industry for a very long time with Sri Rapid Technologies and has worked extensively on FFF, SLA, DLP, SLS, and many more technologies. He is also MIT certified in additive manufacturing and actively conducts training and demos for Sri Rapid Technologies. So let me share you the agenda for the webinar. So today, Pratik will go forward with introduction of Sri Rapid Technologies, and after that we will have a webinar on the given topic. After that, we will also have an interactive poll, which in which we will cover few questions few questions to basically gather insights. These questions are very relatable to topic and your insights on the same. After this poll, we will be having a Q&A session where you have to submit your questions, and these questions you have to submit in the Q&A section. Any Basically, we'll encourage you to submit it there. Any chat in chat section, you can discuss any related issues or something. Okay, so let's start without any further ado. uh, Rohit, please share screen share.
Yeah, thank you, Sonal. Good afternoon, everyone, and thank you for joining us for today's webinar on professional grade desktop 3D printers from Race 3D. So, my name is Pratik 𝗪𝗏𝗪, and I work in the capacity of an application engineer at Shreerapidtechnologies. So, let's just jump right into it. Let me share my screen. The topic for today's webinar is professional grade desktop 3D printers for fiber reinforced composites. Before that, let me just introduce Shreerapidtechnology. So Shreerapidtechnology was incorporated in the year 2007 by partners Mr. Nitin Chaudhary and Mr. 𝗪𝗓𝗓. So SRT is a complete digital manufacturing company providing an end-to-end solution empowering the AM industry. Shreerapid has India's only customer innovation center to offer customers the interactive encounter with the world's leading AM technologies. Shreerapid also is a exclusive race distributor for South Asia. Shreerapidtechnologies is present in the complete digital manufacturing workflow, right from reverse engineering, design, scanning, and to 3D printing and post-processing technologies. And these are some of the brands that we represent, mainly 3D Systems, Race 3D, 3D Ceram, PMF in additive manufacturing technologies. And just recently, we partnered with HBD also for metal printing for specifically for dental applications. Where are we today? And we are 17 plus. We have 17 plus years of industrial experience, and we have presence across the nation with our head office in Mumbai and branch offices in Delhi and Bangalore. We have a team of 95 plus employees, including 40 plus application and service engineers, and we have a base of 850 plus installations across India. We have a customer innovation center for both metal and plastics additive manufacturing technologies. And soon to be added will be ceramic 3D printing as well. A glimpse of what we have here at the Customer Innovation Center. So we have different range of technologies, right from desktop professional grade printers to industrial large scale, large format printers. So come and explore different technologies, and we could discuss your application. We are at 𝗪𝗏𝗧, Andheri East, Mumbai. We are present across multiple industries. I mean, right from engineering to medical and healthcare. You name the industry, and Shreerapidtechnology is there. Some of the technologies that we have and the principal OEM brands that we represent are SLA from 3D Systems, Projection SLA from 3D Systems, Projection Micro SLA from BMF, and SLA for ceramic 3D printing by 3D Ceram. DLP from 3D Systems and Race 3D. Selective laser sintering from 3D Systems and Race 3D, as well as they have just recently introduced a benchtop range of SLS 3D printers. MJP for wax printing as well as plastics printing by 3D Systems. Direct metal printing from 3D Systems, and recently, like I mentioned earlier, we partnered with HBD as well. And of course, we have fused filament fabrication from Race 3D. A short intro about Race 3D, our principal OEM brand that we represent. Race 3D pioneers flexible manufacturing, and they manufacture desktop, 3D printers, professional grade, as well as the industrial grade, large scale, large format 3D printers. And recently they got into DLP printing with the DF2 printer and SLS as well with their newly introduced RMS 220. They are, quite a young company, very innovative company, and it's always been a pleasure working with them. So the topic that I'm going to cover is, I'll be talking about the fiber reinforced composites, the technology to print these composite filaments, the range of filaments available with 3D Race 3D and the compatible 3D printers. We'll go through some applications, case studies, and success stories with these, composite printing. And lastly, we'll look into the Race 3D ecosystem and talk about the idea maker slicing software. So, what are fiber reinforced composite materials? So basically, these composite materials are created by adding chopped or continuous fiber to a thermoplastic matrix. The most popular reinforced fibers are CF, carbon fiber, glass fiber, and Kevlar. They have superior strength to weight ratio, and basically the embedded fibers provide strength and stiffness along the direction they are laid on, while the thermoplastic matrix maintains the cohesion of these fibers and allow them to take the loads. So thermoplastics themselves exhibit much lower stiffness and strength compared to the fiber materials like carbon fiber. So therefore, the infilled fibers can withstand extra loads and stress and boost the properties of these neat thermoplastic materials. So basically, fiber reinforced thermoplastic is an emerging industrial material category with high performance properties, making them valuable solution for high-end industrial application. So the general purpose of composite is to achieve high performance while remaining lightweight, especially compared to metal. Both fibers and plastic components are much lighter. Evenly and randomly distributed fibers can enhance the thermoplastic component strength in all directions. Therefore, when a reinforced part is loaded with stress along the fiber's direction, the fiber can strengthen itself as good as metal probably. So the technology of compounding and blending chopped fibers into the thermoplastic matrix was leveraged to make 3D printable filaments. And triple F 3D printing technology or fused filament fabrication technology is that additive manufacturing technology that enables the process of fabricating fiber reinforced thermoplastic parts. Almost all 3D printing thermoplastics such as ABS, PC, PP, or PA or high performance polymers like PPS can be reinforced with fibers. And with 3D printing technology, it becomes easy to fabricate thermoplastic parts in any shape with the fibers evenly distributed inside. So those of you who are new to this technology, basically it contains a spool of filament which is fed through the extruder or the feeding element and into the heat block or the hot end. The filament is melted and deposited onto the build platform layer upon layer. So producing high performance components with fiber reinforced thermoplastic has been a sign, on the growing demand of manufacturing. With the balance of shape giving and process flexibility, triple F printing using fiber reinforced thermoplastics is promising to lower production costs, reduce production cycle time, and produce lightweight components. So manufacturing sectors, especially automotive and aerospace, can find enormous value with composite filament and triple F technology as they highly prize lightweight properties for their products. And with a wide range of potential applications in prototyping, engineering, and manufacturing, RaceTD offers high-end industrial composite materials. Some of them are the PET-CF, PET-GF, PPA-CF. PPA is polyphthalate from the family of polyamide or nylon. It's like the higher end version of polyamide. And if you see some of the properties, uh, you'll find some common thing that they have a high strength to weight ratio, high like heat. They can sustain high temperatures. Um, they are chemically resistant. They are resistant to corrosion. We also have PA12CF and the supporting material in the form of PET support and PPA support. We'll talk about these supporting materials later on. Excuse me. So this is the E2CF developed by RaceTD specifically for printing carbon fiber reinforced thermoplastics. So E2CF basically has a build volume of 330 by 240 by 240, and it is based on IDEX technology, independent dual extrusion. So what that means is the two nozzles can simultaneously print multiples of the same part in duplicate mode or mirror mode. So E2CF has nozzles with high durability. So then they come with silicon carbide nozzles that have excellent wear resistance and thermal conductivity, which will effectively lessen the abrasion the carbon fiber composite filament subjects the nozzle to when printing. So making the nozzle more durable. And it has a dual direct drive extrusion system. The gears are made of high hardness steel and uh, are heat treated for higher wear resistance. And also it has the extruder has a custom gear tooth profile. So filament is firmly held in place to ensure that it does not slip when extruding. And also they give enough force to ensure stability of printing. E2CF also comes with the dry box to keep the filaments free from moisture or dust. So the built-in suspension tray is where you can load the filament, and directly through the dry box you can pull in and load it directly into the printer. The profiles of the filaments are optimized for first run success. That means that 1 second. Yeah, 1 second. Hold on there. Yeah. So the profiles are optimized for first run success. Uh, that means that the templates for printing raised filaments are already available. Keeping in mind the nature of the filaments, the highly abrasive CF and GF filaments, uh, and the hardware of the extruder. The specially developed breakaway support filaments from RAID, so to make for the overhangs, basically to have a proper interface between the support and the model that is being printed. And these are more cost effective than the water soluble supporting filaments, and they are so easily removable after printing, and without compromising the bottom surface quality. Now, as I mentioned, that these filaments have are heat resistant. They have uh, like high strength to weight ratio. They are corrosion resistant. So because of these properties, the application scenarios are aplenty. So whether it is a fixture in a mechanical workshop, a prosthetic, or a customized bicycle frame, so you name the application, and you can implement this printer, whether it's medical, automotive, industrial, or aerospace. So generally, the applications of 3D printing is into rapid prototyping, but it is not so. It is also extended beyond to tooling, such as making jigs and fixtures, or mold tools such as thermoform molds. So we'll look into a couple of case scenarios for thermoform molding application. What you can see here is that earlier, conventionally, these molds were made with aluminum by CNC machining, and the cost was around 500 US dollars. The weight was 5,000 grams, and the same mold can be 3D printed using a composite material. The printing time is 30 days. I mean, compared to what you used to get conventionally in 30 days. With 3D printing, you would get it in 30 hours, right? The part could withstand around 180 degree of temperature. The part weight is around 600 grams, much less than what you can get in conventional method. And cost to manufacture this is just 90 US dollars. A similar application where lead time is 30 days, cost is 220, the part weight is 3000 grams, compared to the 3D printed counterpart where you get it in 25 hours, 400 gram in weight, and just $60 to manufacture. You can see some of the pictures of the part printed out of E2CF. This is actually the kind of print quality or surface finish you get. The surface finish is impeccable what comes out of E2CF. Some of the mechanical components that have been printed on E2CF. Now, the question here is, see, although with the composite filaments, you're able to manufacture a part within hours, But still, some people question as to can we use this composite filament for printing at high speeds? Although these composite filaments are, give quicker results compared to the conventional methods where lead times would take days and weeks. You would get a print from, you would get a part out of a 3D printer within hours. Still, people are not satisfied with the speed. It's probably a human nature that they're never satisfied with what they get. So the question I get is, can you print parts using composite filament at high speeds? A straightforward answer would be no, because you could run into several challenges, or there could be limitations such as poor interlayer bonding. The nozzle might get clogged. There might be nozzle abrasion. And to overcome this, 𝗪𝗡𝗔 introduced the hypercore filaments, having a composite rich core on the inside and a neat polymer skin on the outside. So 𝗪𝗡𝗔 tailored the hypercore filaments to form a fiber-rich inner core, where most of the carbon fibers are well aligned and distributed. The outstanding heat conductivity of the carbon fiber rich core will speed up filament melting in the hot end. And moreover, thanks to the special fiber distribution, fewer fibers are embedded on the surface of the filament, and more residual thermal energy is obtained from the fiber rich inner core. This way you can improve polymer healing and the interlayer bonding. And also you can significantly improve the Z direction strength, the surface print quality, and also the nozzle lifetime will significantly improve. So with hypercore filament, you get hardware and high speed friendly, outstanding stiffness and strength, smooth surface quality, and optimized heat transfer. Also, you can get functional parts with thin wall strength, much better with the hypercore filament. So mind you, this is a comparison between the two based on the high-speed printing. While you can still get good results with the general composite filaments or industrial composites from 𝗪𝗡𝗔, it's just that if you want to run at high speeds, then hypercore filaments are the option. You can also see significant improvement in the properties of hypercore filaments being much superior to general or industrial composites. That is owing to the fact that you're able to embed more CF or GF weight percentage into the thermoplastic matrix. So with hypercore, you can embed as much as 25 to 30% of composite chopped carbon fiber or glass fiber, compared to that of industrial composites, where you can embed as much as 20% maybe. And that's why the you can see the improvement in the properties. And the printer compatible to run these hypercore filaments is the 𝗪𝗡𝗔 𝗪𝗡𝗕 Pro 3 HS series. So you have Pro 3 HS and Pro 3 Plus HS. So Pro 3 has a build volume of 300 mm3. Pro 3 Plus HS has 300 by 605 mm, where you can achieve printing speeds of up to 300 mm per second. It has automatic filament switching, and compatible material are ranging from general PLA ABS to industrial composites, as well as hyperspeed and hypercore filaments. So Pro 3 HS series is based on these four values. One is the high speed printing with high performance composite materials, enhanced speed and accuracy for industrial applications, longer lasting reliability and durability, and finally maximize production efficiency with minimal manual intervention. So the strength, even at high speeds of up to 300 mm per second, the strength, rigidity, and heat resistance are not compromised. And even at that high speed, you can still use the printed components for end use application, for high load application. The predecessor of Pro 3HS was the Pro 3, which would print at speeds of up to 150 per second. And then RaySteady introduced this hyper speed hyper triple F kit, which was like a additional module that you could install in Pro 3 to make it run at higher speeds of up to 330 per second, 300 to 330. So Pro 3HS is basically an upgrade of Pro 3 where you get an integrated hyper triple F module. And speeds can be significantly improved up to 30 to 70%. Again, depends on the model size. It has an enhanced accuracy without losing steps. I mean, it has new closed loop stepper motor with reduced noise up to 27%. Enhanced accuracy, it has an all metal double gear extruder and temperature sensor, fully machined components, and the composite structure hot end with a titanium alloy throat. It has an all metal frame. So what we are talking about here is a robust machine, a robust workhorse which can run for 24/7, you know, continuously using these highly abrasive composite filaments. Hot end optimization with the metal baffle at the bottom so that there's no impact to the model. You can maximize production efficiency with minimal manual intervention. So what that means is, it has an auto filament switching function where if a filament is used up, it'll look for the spool of filament at the other side, and if it's loaded already, it can pull up automatically and start printing. So you get this uninterrupted printing. It also has an RFID filament sensor for seamless functioning. And it is also compatible with the two 2.5 kg filament boxes. So where there's dry box for A2CF. Similarly, you have these filament boxes for Pro 3HS. So you can pull up to 5 kg of filaments if you're utilizing the entire built volume of say Pro 3HS Plus. Pro 3HS is easy to use owing to the fact that it has an Eve Smart assistant for if there are any uh, issues with the print job, it can resolve. It can be resolved with the help of the Smart assistant. It has power loss recovery, and it has automatic detection. Say in case you try to open the door, the print will pause. Airflow manager, auto bed leveling, and also it has live monitoring HD camera. So you can download the Grace Cloud app and you can monitor your prints right from the comfort of your home. It has a rich material selection, like I mentioned earlier. It can print the generic filaments like PLA, ABS, ASA, and industrial composites, hyperspeed filaments, and also hypercore composites. So basically, you can say that Pro 3HS is the all-in-one printer where you can print a wide range of filaments. So whether it's price to value or high performance, all types of filaments can be printed. If I'm not mentioned this earlier, Race 3D printers are open source printers. So where you can print proprietary materials of Race 3D, that is premium industrial hyperspeed and hypercore filaments, and also certified third party filaments, filaments that are certified by Race 3D to be used on raised 3D printers by the Open Filament program. What OFP means is that it's a collaboration between raised 3D and filament manufacturers to identify and select top performing filaments for raised 3D ecosystem. So you can get 250 plus materials from 40 plus filament manufacturers, 300 plus profiles. I mean, the printing profiles, the templates are already there in the software under the OFP program. You can just simply, choose the filament of your liking and just download the template and start printing. Say, for example, you're using a polymaker filament or BSF or ESUN filaments. The templates are already there. The printing profiles are already there under OFP. You just have to download those templates in the slicing software and start using them. Like I mentioned, that applications are not just limited to rapid prototyping, but actually for tooling. Say, for example, you can print jigs and fixtures and positioning tools, assembling fixtures at reduced cost, and you can basically simplify your production. You can make thermoforming molds or blow molds or even carbon fiber composite molds for conventional manufacturing. You can produce parts for end use application by making customized components or small batch parts, or if you want to make spare parts of certain machine or assembly to be made available. Drone and unmanned components are, this particular application is quite trending. So people want to use, material which are lightweight, but also have, much enough strength. One of the case study from a customer where, they manufactured this cooling duct of a motorcycle braking system on the KTM motorcycle. So the complex curved geometry of the component, and they are basically hard to produce and quickly and repeatedly. So the Pro 3 series of printer was used to print this particular part using a PPCF material, polypropylene composite material embedded with the carbon fiber. And the filament was from Braskem, which is like a third-party filament. So by the use of OFP Open Filament program, the template was used for printing. So this particular part took around 16 hours of printing at cost savings of up to 300 to up to 300 euros. Another application from Droog Moto, where they would make these bespoke motorcycle parts for end use application. Basically, the material that was used was ABS-CF. Robotics end use parts by a university, by students from a university for certain competition. There's a same case study where a robot gripper, traditionally made with the metal, which would take 50 days to manufacture, and it would cost around 1000 euros, and it would weigh 2000 grams. The same was printed using a composite material, which took around 20 hours for printing, and the weight was also reduced up to 70%. Sorry, the cost was reduced, and the part weight was around 500 grams. Another example from automotive, where the raised 3D printer and the composite filaments were used for accelerated product development. ThyssenKrupp Bilstein for mass customization using composite filaments. You can see some images of the parts printed out of Pro 3HS. So basically, you can use for rapid prototyping as well as end-use application. And you can find more such applications if you visit race3d.com/applications. Onto the Race3D ecosystem. Basically, it comprises of the Race3D printers, the filaments, and importantly, the Race3D software. So these are the three key elements of the Race3D ecosystem, that pursues excellent performance. A little bit about the slicing software, Idea Maker. It's a free software made available by Race3D, with which you can print in a FFF printer or DLP printer, even the indirect metal printer, metal fuse, and also the upcoming SLS printer. So it has a short learning curve. Whether you're a beginner or an expert in this technology, it is basically made for all. The software is more streamlined, and also it has a remote video monitoring also. Some of the features of this software, this adaptive layer height, different parts, different components in the same build platform can be set with different settings. You can have customizable and also automatic manual supports. Model repairing option is there. You can segment the parts into multiples and later on join them together. Specific and customizable printing templates are available, and you also have this seamless access to material profile library where you can download these third-party filaments, and start printing. Texture generation, so that if there are any visible layer lines, that can be camouflaged by generating textures. So Race3D has won a grand slam of international technology or innovation awards. Right from when they started with the N series, gone up to Pro 2 and Pro 3 series and the E2 series. And adding to this award soon will be the DF2 Plus, which is the latest offering from Race3D. See, although this is not the topic of discussion today, but we can take it up sometime in the near future. So just a teaser of what Race3D is offering currently. So when you compare these two technologies, DLP and FFF printing, I mean, each technology, taking any 3D printing technology, every technology has their own trade-offs, right? Say, for example, FFF is good for productivity, build size, and production costs, while DLP is good for, aesthetics, surface quality, and accuracy. So the trade-offs of the two can overcome if you integrate both the technologies into your product development process, right? So ultimately, you can use it for prototyping or end-use application. So you can stay tuned when we can bring this DF2 technology, DLP technology in probably in the next webinar, and we can learn about the traceable workflow from start to finish. Right. That's it from my side. If you have any questions, we can take it up now.
So going forward, we will be giving some questions, reading out some questions which are being asked to us, and Pratik will basically answer it. So, Pratik.
Yes,
So the first question is asked by 𝗪𝗲𝗕𝗓 Bhupati, and I'm assigning the question, Pratik, and I will also read out to you. So basically, our other audience can also understand the question. So the first question is, what are the geometrics are not printable in FRP composite in 3D printing?
what are the geometries that are not printable in FRP? See, that's the beauty of 3D printer. Basically, you have the geometry freedom. So complex geometries can be printed, and you can leverage the use of the supporting material, supporting filaments. So wherever there are overhangs, without compromising the bottom surface quality. So as long as the geometries are, within the design guidelines. Say for example, uh, point 0.4 is the nozzle dia, right? You cannot print a feature smaller than that, right? At least it should be twice or thrice the size of that nozzle, minimum nozzle dia. So as long as it meets the design guidelines, I don't think there's any limitation in terms of what geometries can be printed. And also, if the geometries are within the given build volume, so there shouldn't be a problem. The limitations or the challenges are when you're actually using the conventional methods of manufacturing. So, yeah.
Okay, so so we have couple of questions from 𝗪𝗘𝗕𝗜𝗏 itself. So the second question he has is, what is the printing accuracy we could achieve?
Yeah, printing accuracy is basically quite a vague topic, There's no firm answer to it. It depends on a lot of factors like uh, the geometry itself, the part, size of the part, whether it's small or big, how complex the geometry is. So if I have to give you a firm number, uh, any plus or minus, that may not be applicable to all the parts that are being printed. So still, if I have to give a number, that would be plus or minus 0.15, plus or minus 0.15 to zero point 0.2. That's the kind of accuracy you can get with
Okay.
triple F printers from RaySTD.
Okay, so the next question is from the same person. Could you please share about the curing temperature?
Curing temperature, you mean the hot end temperature? So,
Uh, yeah.
it is triple F technology. So in triple F technology, basically, you need to have a maximum temperature by which you can print these feedstock filament, whatever filament you're feeding. So Pro 3HS, you can go up to 330 degrees of hot end temperature. So any filament that melts below that can be printed, basically. Curing is applicable to resin-based printing or DLP printing, right? So depending on what resin you're using, you uh, assign the curing wavelength and the heating temperature.
Okay. So another question is how to avoid clogging of fiber in the nozzle.
If you treat the filament right, if you are running the printer in the right environmental conditions as given in the tech specs, uh, if you're if the filaments do not absorb moisture, it is not exposed to dust, I think you shouldn't have a problem. And mainly, if you're using a RaySTD printer, I would suggest go with the proprietary materials of RaySTD, or if not, you can use the certified filaments by RaySTD under their OFP program. If you want to try, some filaments made locally, right? You may have to do some number of iterations before you get the first article or first print right. So we would only suggest to go for a good quality filament. The filament quality also plays a crucial role when it comes to maintaining the hardware of the printer. So the problem may not be with the printer but the filament itself. So you maintain the printer regularly, do the preventive maintenance, use a good quality filament, and you wouldn't face this nozzle clogging issue. Personally, we have faced the nozzle clogging issue mainly because the filament had absorbed moisture. And also, if you are running, a filament at very high speeds, you may face that. Like I mentioned in my presentation, that if you are running filaments that are not meant to be run at high speeds, you may face that nozzle clogging issue. So you are kind of overburdening or overloading the extruder, the feeder gears, you know, and and uh, and if the geometries are quite complex, there is constant extrusion and retraction. So if it is done at very high speeds, you may face nozzle clogging. So you have to follow, proper SOP guideline uh, to avoid all this.
Okay, so the next is, since the 3D printer has two nozzles, can I try two different fiber material reels for printing?
Two materials you can use it on. Not really, actually. You can use uh, a composite material for printing the main model, and a support material for printing the supports when it comes to Pro 3HS, right? On E2CF, although you have two different nozzles, right? Uh, and they are on the same axis and they are printing simultaneously. So for both nozzles are to be loaded with the same filament, because you need to have the same printing profile, the same printing speed in order to print the part. So the answer to that would be no. If you want to use two different composite materials on the two nozzles, then it is not possible. The same material on the two nozzles, or if you're using Pro 3HS, you can use one composite material, and the other would be the support material.
Okay. The next question is from Javed Bhatt. Is the code of Race 3D open source? That is, can users modify the functionality and add more sensors and access the data?
You can do it at your own risk. That's all I can say.
Okay. So please tell us about the price ranges of this printer. Okay. So I think the prices and prices will be discussed with our team further. So we'll move to the next question.
Yeah, you can
The
connect
next,
with the sales team, and you can discuss what are the latest prices that we are offering.
right. So the next question is, have you made any load bearing parts like shaft, impeller, etc. of ceramic with which are normally being made of metals? This is ceramic
Ceramic.
related.
Yeah, I mean the ceramic related, but
Yeah, I
that's
think in
different.
ceramic,
Although that's a different material topic, but with plastics, of course, with plastic components, composites, we have of course printed such parts, shafts and impellers, and basically they have been used for form fit and functional testing. You know, for endos, I mean, although we have printed, but they are quite simple designs. So we have printed in composites. For ceramic, it's a different topic, so probably we can take it up later on, in one-on-one discussion.
okay. So the next question is from Pratapa. How can we improve the quality after printing the parts without layers mark?
How can we improve the quality after printing the parts without layer marks? Some post processing, of course. I mean, triple F printing. That's a technology limitation where the layer marks are quite visible, because unlike uh, uh, resin based printing, where the layers are chemically bonded and the layers are hardly visible. In triple F printing, the fibers are kind of the filaments are kind of mechanically bonded. The layers are mechanically bonded to each other, merely adhering to each other, and so the layer marks are visible. So, in a way, you can do some post processing. Like, say, for example, if you're using like PLA or ABS, you can go for vapor fusing. If you're using composite materials, I'm not really sure if vapor fusing works with the composite materials. We'll have to look into that. But You can improve it by sanding, or you can apply some epoxy coating so that the surface finish looks much smooth. For vapor fusing, of course, I'll have to look because that could be an option if the composite materials could be done with that.
Okay. So we have another question that is from Serena itself from Race 3D.
Yeah.
So hi Pratik, how good is the low temperature performance of composite filaments? Can they survive in temperature of minus 40 degrees Celsius? Thanks.
Yes, they can. So up
Okay.
to 40, even 50, say with the PPACF, PPAGF, they can survive in low temperatures of up to 40, 50 degrees. And for your information, RayStudy is also going to launch uh, a composite material which is PPS, polyphenylene sulfide, PPSCF. Uh, I'm talking about the high temperature sustainability that can sustain temperatures of up to 250 to 60 degrees, right? So 40, 50 in the negative, and up to 250 degrees at uh, the higher level.
Okay. So this is a last question which we have for the session. Is there any way to conduct institute monitoring for stress generation during printing? You have mentioned about a camera which could show the printing video, but how about stress generation monitoring?
No, that the camera is not that advanced. I mean, you can only monitor your print through the laptop or the phone if you're using the Race Cloud app. So only monitoring is possible.
Okay, so actually we got two more questions at
Yeah.
last moment. What is the maximum melt and the chamber temperature?
It doesn't have neither Pro 3 or E2CF. They don't have chamber temperature, active chamber temperature. But what they have is the passive heating, passive chamber temperature. So whatever heat is generated by the hot end and the heat bed is what is being circulated inside the chamber. So we have not measured it, how much temperature or heat is generated inside the chamber. Probably it could be 60 to 80 degree. So, and the print bed can reach up to 110 degree, can be heated up to 110 degrees, and the hot end temperatures can reach 300 to 330 degrees.
Okay. The next is filament method is good in 3D printing of marine engines and in automotive components? Question mark. If so, please share the example. Okay.
Yeah, for automotives, you will find a lot of case studies. The one I've already mentioned, I'm talking about end use application. I mean, they have been used in automotive applications, industries. And if you want to find out more, you can find out through that website, raceready.com/applications. For marine engines, we'll have to check if there are any. But uh, say just for an example, if you're using components in seawater, they are compatible. I mean, they can run, they can function without any problems. But if there are any specific case studies related to marine application, we'll have to check. Probably we can, you know, check and get back to you later.
Okay. So Pratap has again another question. Is there any sensor in machine parts will get will get the fail automatically? It will stop.
Is there any sensor in machine? Parts will get the fail automatically. It will stop. Yeah, of course.
Sensor
If
in
something, uh, yeah, I mean, if something fails, I mean, it depends on which sensor fails, basically. So if a sensor fails, basically machine has to stop. But if any specific particular sensor you're talking about, we'll have to look into that.
Another question from Muralitharan seems to have a lot of questions. Can we use nano material as polymer matrix material with this 3D printer?
Nanomaterial as polymer matrix material. You mean the nanofibers? I'm not really sure.
Okay.
I mean, there have been a lot of research based on, I mean, what reinforced material can be used with the thermoplastic matrix, right? I myself have research with PLA with natural fibers like sisal and jute, right? So there are some nano materials, nanofibers that are reinforced with the thermoplastics. Yeah, nanofiber. So uh, you can develop your own thermoplastic, and you can run on this printer. That is possible. So, like I said, that the race 3D printers are open source printers. So, if you are developing your own material, you are of course free to test it out on race 3D. Uh, but the thing is, the catch is because the printing templates won't be available, but the settings are open for you to test it out and do some hit and trials to make your filament, your own custom filament, run on these printers.
Okay, so that's all for the questions we had for today. So I would like to thank Pratik for such an immense knowledge which you have shared with all of us. And also going forward, I also like to thank the Sri Rapid Technologies for organizing this webinar and making it a success. Last but not the least, thank you to all our attendees and all the questions which you have been asking. And any more questions you would like to ask further, we would request you to connect us on the mentioned number, and our team would help you with all your queries. Also, we will be sharing this webinar video with you through email. So please do check your email IDs for the same. Also, before ending this session, I would request attendees to fill up the quick survey after the webinar ends. Also, please stay in touch for further webinars and insightful sessions. Finally, thank you everyone. Have a great day ahead. Thank you. Thank you.
Yeah, and if you are in Mumbai or nearby Mumbai, you can come down to our customer innovation center and see the live printing. See all the printers that we have. If you have any demo files that you would like to print, you are please welcome to visit us anytime.
Yes, the photo which you see currently on your screen is from our customer innovation center. So we have printers there, live printing goes on, and you can also meet Pratik, our application expert there. And any queries, anything you have in mind, we basically can answer your questions. Okay. Thank you, Pratik. Thanks a lot.
Thank you, Sonal. Thank you all. Bye.
Thank you all. Bye.